I want to welcome each of you to the Manhole Rehabilitation Techs and Specs webcast, sponsored by NASCO with the support of Avanti International and Parson Environmental Products. Before we begin, I would like to quickly review a few logistics. WEF will no longer be using FTP sites for the webcast information distribution. However, all of the PDF PowerPoint presentations are available for downloading at WEF's website. This link was distributed via email yesterday and will be distributed again tomorrow for anyone that registered after the time of distribution. This email also included a link for the webcast Professional Development Hour instructions for those eligible to receive these training credits. There are 2 PDH credits for this webcast. You will need to complete the evaluation form to receive the PDH certificate. Your feedback on this webcast is important and helps identify future webcast topics that are timely and helpful to you. Please follow the PDH instructions and check with your state accreditation agency on how to receive this credit. If you have any questions about this new process, please feel free to send me a message during the webcast or an email at webcast@wef.org. During this webcast, while you cannot speak directly to the presenters, you will, however, have an opportunity to submit questions by typing in your specific question via the pane that appears on your PC. Today's moderator, Ted DeBoda, will be accumulating questions and direct them to the presenters throughout the webcast. We will be recording this webcast. A link will be sent to all registered users tomorrow so that you can share it with other colleagues who could not attend the webcast. Again, if you have any questions after the webcast has ended, please email webcast@wef.org. I'd like to thank Ted for moderating today's webcast. Ted DeBoda is the Executive Director at NASCO. Ted?
Thanks, Rebecca. Hi, everyone. Today's webcast is titled Manhole Rehab Techs and Specs. My name is Ted DeBoda, and I'll be your moderator for this afternoon's webcast. This webcast is being sponsored by NASCO, the National Association of Sewer Service Companies, with support by Avanti International and Parson Environmental. And I want to thank both of those organizations for their support of NASCO in general, and in particular for this WEF webcast. You'll have an opportunity to learn more about these companies at the end of our webcast. Now, NASCO's main goal over the past 38 years has been to improve the success rate of everyone involved in the pipeline rehab industry. So having said that, our one goal for this webcast is to improve the success rate of your manhole rehabilitation projects. Now, we have a lot of good information to cover today. Some of the key points in this webcast include assessment. We'll provide a brief description of manhole assessment and how that leads to selection of specific rehabilitation technologies. That will be followed by 4 experts in manhole rehabilitation technologies to discuss some of the predominant rehab technologies available in the market today. We'll then move to the importance of good manhole rehab specifications, emphasizing some of the important components of a good specification. Now, following this webcast, you'll be provided instructions on how to download your own free copy of NASCO's specification guidelines, which was developed by our own Manhole Rehabilitation Committee, some of which you're going to hear from today. And finally, the perfect specification is really not worth the paper it's written on if it's not thoroughly executed. So we'll wrap up the webinar with a presentation of key components of construction inspection for manhole rehabilitation. Now, our presenters this afternoon will include John Schroeder from CDM Smith to discuss manhole assessment. For manhole rehabilitation technologies, you'll hear from Frank Aguilar from Avanti International, Craig Gall from Parson Environmental Products, Jim Creed of Sherwin-Williams Company, and John Manajak of National Power Rodding, a Caroline Corporation. Tim Back from Back Municipal Consulting will discuss the specification guidelines that were developed by NASCO's Manhole Rehabilitation Committee under his leadership. And finally, Jerry Munchmeyer, NASCO's Technical Director, will explain some of the unique inspection techniques that are required for successful manhole rehabilitation projects. Now, as Rebecca mentioned, we'll take we have 2 times set aside during the webcast to answer questions. As your questions come up, go ahead and submit them. We're going to address as many as we can in the middle and at the end of this webcast. But if we can't get to all of your questions, really don't let that stop you from submitting them. After the webinar, we'll submit all the questions to the panel, and then we'll provide you with a link We'll follow up with emails and provide you with a link to access the answers in the form of a FAQ or a frequently asked questions list. So having said all that, our first speaker will be John Schroeder. John is a professional civil and environmental engineer and an associate with CDM Smith. With over 21 years of experience in planning, assessment, rehabilitation, asset management, design, and construction management of underground pipelines, he's their technical discipline leader in pipeline assessment and trenchless technologies. John resides in Columbus, Ohio, and has a bachelor's degree in civil and environmental engineering from the University of Cincinnati. He is a board-certified environmental engineer by the American Academy of Environmental Engineers. John's a former board member of NASCO and a PACP master trainer. He also serves on NASCO's Infrastructure Assessment Committee, Manhole Rehabilitation Committee, and Pressure Pipe Committee, just to name a few. John?
Thanks, Ted. I'm going to be covering, as Ted said, the assessment portion of this program. With the success in the national acceptance of PACP for pipelines, there was a natural progression in the industry to add manholes and laterals to the NASCO training programs. So in 2010, we recently modified MACP to allow several different types of manhole inspections, known as level 1 and level 2. So with level 1, we're trying to gather basic information from the top of the manhole, not entering the manhole, to get some basic information. And one of those things is to find out if a level 2 inspection is necessary. So maybe you have some defects that you want more information about. So the level 2 type of inspection allows us to gather more detailed information to fully document the dimensions and the pipe connections and defects within the manhole to provide us enough information to make intelligent decisions on whether or not and what type of improvements or rehabilitation is necessary. The level 2 does require either specialized cameras and equipment to be used or for man entry. They have mandatory fields that have to be collected, but it's flexible enough that allows us to collect specific information that's, say, not mandatory for the needs of each individual project. We are updating this program, MACP, in 2014, so if you do have any suggestions and you have used this program, if you have any suggestions, please pass that along to myself or anyone within the NASCO program. So what you see now is a profile view of manholes, a brick manhole on the left and a concrete manhole on the right. And what the MACP program does, it lets us look at the manholes as almost a vertical pipeline, starting with the cover, the frame seal, the chimney, the cone, and then the wall sections, all the way down to the bench and the channel and all the pipe connections. So we're going to be using all those components to collect all the pertinent information that's needed for each individual project. With everything else in the trenchless industry, it's constantly changing, and there's new and innovative trenchless technologies that come out every year that allow us to collect better, faster, more detailed data. And what you see here is just some different snapshots of pole cameras that allow us to collect video and or photos of the manhole, as well as zooming up inside the pipe. And I personally have used these types of technologies, and it gives us sometimes a good snapshot, zooming up the pipe to see if that pipe is open or clear, or maybe that's blocked or has too much flow in it. Another technology that has really come a long way in the last couple of years are these panoramic cameras. It allows us to do a very thorough and quick inspection in less than 5 minutes of the entire interior of the manhole, and we can then take that information and actually do full-blown level 2 MACP inspections back in the office, where we complete all the fields by entering all that information into the computer. Again, you can do, in 5 minutes you can collect all this information, the video, and then take that information back to the office. So what you see now is the summary sheet of all the level 1 and level 2 MACP inspection fields for the basic information. So, and you can see levels 1 and 2 in red, which ones are mandatory. So if it has a 1 or 2, it says whether or not those fields are mandatory for a level 1 or level 2 inspection. The next information that you may collect, especially when you get into level 2 inspections, is information on the pipes coming into and out of the manhole. So we're going to collect information like the clock position, the depth or rim to invert, the material of the pipe, the shape of the pipe, diameters, some general condition, is it good or is it bad, and any type of seal condition. The defect coding, as I mentioned, we've taken the PACP and really are reusing almost all of the codes that you would see for defects within a pipeline and using those same codes for the manhole. So things like infiltration runner is IR and missing mortar, and we're using those same types of code all the way from the top of the manhole at the cover all the way down to the bottom, which is the channel. And then we also use abbreviations for the cone and the wall and the channel. So we are using those abbreviations to complete this type of defect coding information. And then we will also identify, severity of the types of defects and the clock position within the manhole. So with that information that we're going to collect, we're always trying to figure out, okay, does this manhole need any type of improvements? And if so, what might those improvements be? Also in the field, we utilize a lot of other types of technologies like handheld GPS data collectors that we can pre-populate inspection forms that we can just basically have pull-down menus. We can collect XY coordinates of the manhole location, which we can bring back and put that into our GIS. And we can, rapidly collect all this information in 10 to 15 minutes per manhole. Here's a couple of sample manhole inspections that we've done on some recent projects, and I'd like to, again reiterate that, each project's different. The information that you may need is different, and the MACP kind of gives us just some basic fundamentals of the fields and standardization of an access database that we can collect all this information in a standard form. Here's a snapshot of, some basic information of we're collecting any infiltration, the material, the dimensions, some condition information, and then we usually typically take several photographs that we can put into this form, and then we can have one file that may be used to, say, link to the GIS. It's important to be able to collect this information efficiently, so that's really why we've kind of collected these pull-down things. We can kind of check off what the material and condition is for each component of the manhole. The information you might get with a MACP database, an Exchange database, there's a lot of information that's collected, and you're going to get this type of information. Here's a sample MACP Exchange database, and the key table that you get, all these are individual tables, but the key table that you're going to have all your summary information is the manhole inspection table. The benefit of having all this digital information, I think, is much more powerful when you get this information and you can link it to your GIS, and you can then collect this information and summarize it and have maps and thematic maps of where all your problems are, and so you can identify your defects, your types of manholes, your depths of manholes, and you can correlate that. These stars here are where we had SSOs, and so you can kind of have all this information in one location. And you can also identify, what your recommendations are. So if you made recommendations for various types of rehabilitation, you can also show that on your GIS. So that's really a quick summary of the inspection of different types of technologies and different types of methodologies. Now I'm going to turn it back over to Ted to introduce the rest of our speakers.
Yeah, thanks a lot, John. In this next segment, you're going to hear from 4 industry experts in manhole rehabilitation technologies. Now, the first of our speakers will be Frank Aguilar, Vice President of Operations and Customer Service at Avanti International. He'll discuss chemical grouting in manholes. Frank has experience with R&D, technical support, vendor management, and international sales. He also speaks 4 languages fluently. And Frank, if you can do this in English.
I'll be happy to do it in English. Thank you, Ted. Welcome, everyone. Glad you could be in attendance today.
Frank, if you just click once on the slide, it'll activate it.
Today I'm talking about how manholes are vulnerable to infiltration through cracks, pipe penetrations, faulty seals, and sometimes, yes, poor installation. With the service line, lateral connection, and mainline joints being sealed using a remote grouting packer, the next component for eliminating infiltration is the manhole. Manholes are at times the most accessible with a high rate of return on your efforts. You can see the results right away. The main types of manholes serviced by chemical grouts are brick and mortar and precast manholes. Over time, the mortar slowly erodes away, exposing the manhole to leaks. And in the precast concrete manholes, the gaskets are rolled or torn during installation, creating an entry area for infiltration. Let's review a number of techniques for sealing leaking manholes. One is vertical crack injection, horizontal joint injection, occam soccam, curtain grouting, and probe grouting. The following animations will help us understand what can be done to stop leaks in a manhole permanently. In this vertical crack injection animation, you see the leaking manhole, you see the water coming in, you see that injection holes are being drilled from typically the lowest point. You drill at a 45-degree angle toward the crack, a distance off the crack equal to about half the wall thickness. You would typically drill on either side of the track. You would then flush the cracks with water to remove any debris and then install the injector. The injector is placed and tightened into the wall structure. Using a grout pump, you set the pump at its lowest possible pressure. Then you would connect the coupler to the injector. You would begin pumping grout until the grout stops accepting the material. The process continues. He works his way up. As you can see that the water is slowed down until there is no more water coming through the manhole wall. In the horizontal crack injection animation, you see the leaking manhole. Injection holes are drilled in a horizontal pattern. You would then again flush the cracks with water to remove any debris and then install the injector. You're not trying to drill all the way through the structure wall, so again, keeping in mind the thickness of the wall is important. You would then install the injector in place. Using a grout pump, you would set the pump at its lowest possible pressure, then connect to the coupler to the injector. You begin pumping grout until the area stops accepting the material. In the final phase of the animation, you see the grout traveling. You see the next grouting area being injected, and you see the grout travel to the other side. In the Occam-Socam animation, we see a wall that is leaking. You see the Occam rope and you see the grout pail. Typically, the grout is mixed into the Occam rope to keep the grout in place as you put the mixture into the leaking area. After you place in the leaking area, the material will expand, it adheres, and compresses against the sides of the structure, stopping the leak. Sometimes the manhole has too many leaks to effectively treat each individually. In that case, it can be curtain grouted. In the curtain grouted animation, we utilize a brick manhole that is leaking. We observe a grout probe that is injecting grout all the way through the manhole wall out into the surrounding soil. The process is stabilizing the soil and creating a permanent curtain outside the underground structure. The process is continued again from the lowest point up, and you see in the animation how the grout is forming a mixture with the soil matrix, stopping the water. The last technique we will review is probe grouting. This approach may be warranted if there are too many types of utilities in the manhole, for say, or if you have very limited access. The animation shows how a contractor may perform the work in a brick manhole. The probe may be jetted with water pressure or high pressure air to the depth desired. Install all pipes in the area to be grouted. Ensure that the pipes are fitted with the appropriate fittings for a proper connection. Each injection pass will receive about 1/4 gallon of material depending on the soil type. After the desired amount of grout is injected, stop pumping and pull the probe up approximately 2 feet. Inject again using the same technique. Continue the process until the probe is within 3 to 5 feet of the surface of the ground. These techniques are at times the first wave of defense before other technologies can be used. Today we've reviewed techniques which are long-term solutions for leaking manholes and our aging infrastructure. Back to you, Ted.
Yeah, thanks, Frank. Our next speaker will be Craig Gall, who will talk about cementitious rehabilitation of manholes. Craig's the owner and president of Parson Environmental Products and has 30 years of experience in manhole rehabilitation and I&I solutions. He's trained contractors and municipalities in both the classroom and in the field. Craig?
Thank you, Ted. Good afternoon, everyone. In this segment of the program, we will present the different types of cementitious lining products that are available for sanitary sewer manhole rehabilitation. However, before we begin that portion of the presentation, it's best that we start at the beginning of the rehabilitation process. The long-term success of the cementitious lining product is directly related to the level at which overall surface preparation, including cleaning, leak stopping, and patching, are accomplished. If any one of these steps is completed at a subpar level, it could and usually does compromise the quality of the finished product. Although any failure would appear to be that of the cementitious lining, it is more likely that one or more of the procedures leading up to the actual product application may actually have been at fault. A qualified contractor trained by the product manufacturer, along with that of the product manufacturer, is on the line in every manhole in the project. Inspection should take place before, during, and after the work in order to ensure that all procedures have been completed properly. Surface preparation. Though thorough and proper surface preparation is vital when considering the importance of the adhesion of the cementitious lining to the vertical manhole wall. The lining must be bonded throughout the structure from the underside of the manhole frame to the bench. The surface preparation method of choice is water blasting at around 3,500 psi. This is normally sufficient pressure to remove unwanted dirt and debris from the manhole in order to begin the lining process with a clean, sound surface. A sand-assisted water blast at those pressures can be used if a more aggressive type of cleaning is needed. Care must be taken not to use excessive pressure, as that may cause unwanted damage to the manhole structure. Stopping active leaks is also a key element that will affect the bond of the lining product to the manhole. Cementitious lining materials are not designed to be applied where active leaks are visible. Their set times are too long for the products to have the ability to stop moving water. Use of fast-set hydraulic cements and urethane acrylic or acrylamide grouts is necessary to establish a leak-free manhole surface. Cementitious patching materials can be used to fill in gaps, voids, or holes that may be excessively deep prior to installation of the cementitious lining. Most of the manufacturers offer this type of product that is compatible with their lining material. This is an important point to consider when placing more than one surface bonding product in the same manhole. Set times for patching materials are usually in the 30-minute range. Cementitious lining materials are designed for manhole rehab are typically manufactured from either Portland or calcium aluminate cements. Even so, all of the products using either type of cement are designed to provide structural integrity, protection against future infiltration, and corrosion resistance of varying levels, which we will discuss later. Compressor strengths are typically 4 to 5 times greater than the existing manhole substrate, which will return the manhole to better the new condition by providing a higher level of structural integrity. They are usually fiber reinforced to aid in resisting surface cracking and require around 1 to 1.25 gallons of water per bag, with bag sizes ranging from 50 to 75 pounds. The products have very good adhesion to the manhole substrate, along with internal cohesion that allow for vertical and overhead applications without the use of wire mesh or other supporting materials. Each manufacturer has their own design philosophies, which are reflected in their proprietary formulations that determine how their particular product will mix, spray, and finish. However, the products manufactured within each cement group will typically possess similar physical properties and long-term performance. Just as Fords and Chevys are manufactured by different companies and take their own approaches to certain aspects of their vehicles, they're both designed to get you from point A to point B. Wet shotcrete spraying, either by gun or spin caster, is the most common application method for these products, but most can also be applied by trowel if necessary. Recommended application thickness is a minimum of 1/2 inch, which can be increased depending upon the product's capabilities, along with engineering design parameters that may be part of the project specifications. The products are finished using a steel trowel to compact the material and close up the pore structure. A subsequent brush finish is optional and may be performed if desired. Common types of these products include Portland cement with aggregate, which is typically a fine-grained sand, calcium aluminate cement with select aggregate, calcium aluminate cement with calcium aluminate aggregate, which is referred to as clinker, and it is a byproduct from the processing of the calcium aluminate cement, and also Portland or calcium aluminate cement-based products with a liquid additive to prevent growth of bacteria that causes microbial-induced corrosion, or MIC. Portland cement-based products will usually exhibit the longest working times. This type of product can typically be applied at a thicker rate per coat than calcium aluminate-based products. The 28-day compressor strengths are typically a bit higher than the calcium aluminate materials, which gain strength much earlier in the cycle and then tend to move upward more slowly. Portland cement-based linings may be the most commonly utilized cementitious linings due to a lower cost, acceptable corrosion resistance for a majority of environments, and a more user-friendly application due in part to the extended working times. Calcium aluminate cement with select aggregate products usually have a reduced working time versus Portland cement due to the increased internal heat that is naturally generated by the calcium aluminate cement. And as the ambient temperatures increase, that working time may be reduced even further. Corrosion resistance is enhanced to a moderate level, and it is usually at a mid-range price point. These products tend to be a little more difficult to handle versus Portland cement due in part to working time constraints, but factory-trained contractors are capable of installing the products properly. 100% pure fused calcium aluminate cement with calcium aluminate aggregate products arguably have the highest resistance to corrosion due to the addition of calcium aluminate aggregate, which is much harder than sand. The product has similar working time characteristics to calcium aluminate. There are only several manufacturers that can provide this type of product, however, as calcium aluminate aggregate is difficult to obtain. Portland cement or calcium aluminate cement base with a liquid additive introduced during the mixing process can eliminate the growth of microbial-induced corrosion, or MIC, which is a primary cause of corrosion in manholes. It guards against the growth of mold, fungi, algae, and other unwanted bacteria, which in turn does not allow damaging sulfuric acid to be produced. Also, it remains a permanent part of the concrete matrix. Famous concrete structures include the Hoover Dam, the Panama Canal, and the Roman Pantheon. The earliest large-scale users of concrete technology were the ancient Romans, and concrete was widely used in the Roman Empire. The Colosseum in Rome was built largely of concrete, and the concrete dome of the Pantheon is the world's largest. After the Roman Empire collapsed, use of concrete became rare until the technology was repioneered in the mid-18th century. Today, concrete is the most widely used man-made construction material. Sprayable high-build cementitious linings have revolutionized the manhole rehabilitation industry over the past 25 years or so and taken it to a new level of long-term sustainability. Providing structural integrity is becoming more and more important as our already old infrastructure continues to age. Cement has been used in some of the world's oldest structures that are still standing today. Manholes lined with any of the cementitious products discussed here today should be around long after all of us are just a memory. Thank you for your time. Enjoy the remainder of the webinar. Back to you, Ted.
Thanks a lot, Craig.
You're welcome.
Our next presenter is going to be Jim Creed. He's a senior protective coating specialist with Sherwin-Williams, and he'll discuss the use of polymers. Over the past 25 years, Jim has served multiple roles within the Sherwin-Williams company, and in 2000 he took over the heavy-duty protective coatings market in Chicago, Illinois. He's currently working with infrastructure rehabilitation in water and wastewater, as well as bridges and highways in Chicago. Jim?
Jim, just remember to unmute your phone.
Do we have Jim? Jim, are you muted?
Ted, let's go ahead and move to John Manajak's presentation, and then I'll work with Jim to get back online.
Okay. Okay, John, our next speaker is John Manhole. John's with National Power Rotting, and he's going to talk about manhole chimney rehabilitation. John's been with National Power Rotting, a Carillon corporation, for over 15 years. He currently serves as a project manager, and he's in the field on a daily basis. So, John?
I hope you can hear me.
We can hear you. Thanks, John.
Okay, very good. Thank you very much, Ted. Hello, everyone. I hope you're enjoying our webcast so far. My name is John Manhole, and I'm with National Power Rotting, part of the Carillon Corporation. We're headquartered in Chicago. My portion of this webinar is to cover the chimney rehab and repair. First of all, let's make sure that everyone here knows what a chimney is. When we talk about a chimney of a manhole, we are speaking about the area just below the frame and extending to the corbel area. As you can see, I've circled this area on the illustration in red. The chimney area is primarily for the adjustment of the frame in relation to the surface area. Our most common problems occur because the chimney is so close to the surface. Chimneys and the material that makes up the chimney are exposed to the elements, especially when we have an open grate manhole cover like those that are used in storm inlets and catch basins. The chimney is where we find the most damage from the freeze-thaw cycle. Manholes located in the streets experience damage to the chimneys from the constant pounding from car and truck traffic. With the constant pounding of traffic and the yearly freeze and thaw cycles, chimneys are prone to infiltration because of the breakdown of their material. It is said that about 50% of the initial inflow from a rain event occurs at the chimney area. Chimney repairs can be categorized as either exterior solutions or interior solutions. Exterior solutions require an excavation, or they must be installed during construction prior to leveling the surface. The interior solutions, or ones that don't require a dig, can be installed from the surface, and about 75% of the time they do not even require a manned entry. If your chimneys are in good shape, or if they have been previously rehabbed, these two items will help eliminate inflow. The manhole cover inserts, they sit between the cover and the frame, and they catch the water as it comes in through the cover holes. Pick hole plugs simply block the water from entering the cover openings. They are a relatively easy fix, and they require very little training to install. The first of our exterior solutions would be ring replacement. This is commonly used when resurfacing a road or making frame adjustments. Older chimneys that are made out of bricks, or ones that have the cracked rings, can be replaced with the concrete rings, and a butyl rope will be placed in between each one. Modern materials such as the black composite that you see on the left are lighter, and they can be made in different thicknesses. The external wrap is best installed when adjusting frames or during new construction. These help protect from infiltration from the outside and are held in place by the metal bands. Moving inside, the first thing that I think about when I hear about a chimney seal are the internal boots. This is a rubber ring of various diameters that is installed against the frame and extend downward to the corbel area. They're held in place by stainless steel bands that lock in place. They are best used if you have a fairly even ring size for the length of the chimney. However, they do give you a little bit of stretch. So if you have a 22-inch ring and a 23-inch ring in the same chimney, the boots will be able to cover both sizes. Chemical grouting is performed in the same manner as manhole grouting. The operator will drill through the wall and inject the chemical grout to form an external chimney seal. This can also be performed from the surface down by drilling through the ground and injecting from above. The newest type of chimney seals are hand-applied or sprayed-on chimney seals. These are used when you have irregular chimney sizes or oddly shaped ones such as those that you may find in the square inlet boxes. These will give you about a 500% elongation and are chemically resistant to road salts. And finally, to wrap things up, chimneys are the area of the manhole that are most exposed to the elements. Because of the constant pounding of traffic, they are prone to material breakdown and movement. Repairs can be made using internal or external solutions. These solutions will help eliminate infiltration and inflow and help protect against the road salts. And thank you very much. And Ted, back to you.
Okay, thanks. Thanks, John. Jim, are you with us?
Yes, can you hear me now?
Yes.
Excellent. I apologize about the technical difficulties, but let me go ahead and appreciate and welcome and good afternoon, everyone. The learning objectives and overviews that we wanted to talk about today were causes of deterioration in concrete municipal infrastructure, reducing or stopping the inflow and infiltration, structural rehabilitation, the materials, as well as the chemical resistance coatings and linings that are being used today. Let's talk about some of the causes of deterioration. Structural fatigue, corrosive gases, microbial-induced corrosion, as well as old age plague our infrastructure. Some of the causes include structural fatigue, and this is induced by traffic loading, freeze and thaw cyclings, soil movement, as well as erosion. It's a picture showing multiple cracks around the manhole. Some of the corrosive gases that we come across are obviously hydrogen sulfide. It's corrosive to metal and concrete. It reduces the pH level, and it converts to sulfuric acid when it becomes in contact with sulfur-reducing bacteria. Another gas is carbon dioxide. It's slow deterioration of the substrate. It's naturally occurring, and it acts to reduce the pH of the substrate, and it leads to carbonated concrete. There's generally 4 phases of MIC. Phase 1, sulfur-reducing bacteria break down sulfates in the waste stream and produce hydrogen sulfide as well as carbon dioxide. Not something that's visible. Neither one of the first 3 phases are visible. Phase 2 is where these acidic gases and carbon dioxide act to reduce the pH concrete from approximately 12 to as low as 9. And these sulfur oxidizing bacteria attach to the surface as sulfates are produced. Phase 3, these SOBs are known as dialbacillus dioxidins. They consume H2S and discharge sulfuric acid. The pH continues to drop, and the microbial growth accelerates, creating more and more acids. Phase 4 is where we generally see the corrosion. The acid attack of the concrete layers creates gypsum. These organisms continue to reproduce, additional acid is produced, and then there's eventual structure failure. This particular picture on the left shows how bad the acid ate away the concrete and exactly what we're talking about. Here's another picture. Above the waterline, you can see how bad the corrosion is of steel as well as concrete. How do you stop I&I? And what's the purpose? Obviously, the purpose is to lower the cost of wastewater being treated, to lower the cost of the equipment maintenance associated with abrasive soils, and to protect the environment for either the sanitary sewer overflows or the combined sewer overflows. It's a repair of a manhole after a lot of I&I was fixed using hydraulic cement. Let's talk about the types of chemical resistance coatings and linings. There's epoxy resins, elastomeric polyurethanes, and polyureas in both pure and hybrid formulations. Epoxy-based resin linings have been used and has been the industry standard since we began lining manholes. Again, they're not the cure-all or fix, and every coating should be considered based on the structure, location used, and then the environment during application. Some of the pros of these epoxies are they are moisture tolerant. They go to surface saturated conditions. A very high film build, 125 to 250 mils or up to 1/4 of an inch. Very high strength, very low or no odor. They're generally 100% solids. They are very chemical resistant. They come in variable formulations, and the resins can be hot pots or applied very quickly through standard equipment or through fluorocomponent spray. These epoxies can also be made into mortars and hand troweled into place. The kinds of these linings, well, subject to blush. There's certain constituents in this product that create a waxy film on the surface. That doesn't really matter, it's in a manhole. The exothermic reaction, though, if the materials are applied too hot, they are going to cause a cracking or a brittleness of the film. That's a completed manhole with an epoxy coating. Another epoxy in a wet well. Nice epoxy coating in headworks. This particular manhole, although the picture is not the best, had complete aggregate showing, and there's 250 mils or 1/4 inch epoxy in this structure that brought it back to life, extended the life per se. Talking about polyurethane coatings and linings, the pros are flexibility. They're very flexible, 50, 60% elongation. There's also rigidity in their film, which is kind of an oxymoron with something flexible also being rigid. It can be hand applied with certain technology, but it has very good elongation, fast cure times, and very good abrasion resistance. And again, up to a 1/4 inch or high film builds. The con side are it does not tolerate moisture at all during application, so it cannot go over surface saturated. It must be sprayed through a plural component pump, and it must require a primer. That's a elastomeric polyurethane, and if you notice, this is a new structure, so they have the ability of priming and top coating it. Polyurea coatings and linings, they've been the newest technology, but they've been around for a while. It's really hard to evaluate. There's so many different formulations. The formulations can also affect the chemical resistance of the coatings. The pros are they're very fast drying. Again, very high film builds. They're used for linings, chimney seals. They're physically tough, very good abrasion resistance, very good elongation up to 530%. And on the back side, they don't tolerate moisture at all. They must be applied with plural component, which is sometimes bulky, although there has been some robotic plural component in the market. Some have very poor chemical resistance for the most part, but again, that depends on the formulation. High tensile strength, and generally a primer is always required. We talk about holiday inspection, and I bring this up as a safety. When we're talking about thick mill coatings, anything over 20 mils, you have to have 100 volts per mil. So we're talking about high voltage. Just be safe when you're using these tools. This shows a picture of the elastomeric polyurethane being spark tested. And in summary, there's numerous products and methods that are available for lining and rehabilitation of sewer infrastructure. These physical performance characteristics, they vary greatly across these various and numerous chemistries. Products should be selected based on the need of the end user. And uniform monolithic films definitely aid in the prevention of chemical attack. Thank you very much.
Thanks, Jim. We have some time to take some questions now. I'm going to tell you we've gotten, I think I counted about between 40, 45 questions. We've got a lot of questions coming in, and I think that's great. It really shows a lot of interest in what we're talking about. So I'm going to try to address questions to each one of our speakers. But again, I want to remind you, if you have questions, please keep sending them in, because we will follow up with answers to all these questions based on the, we'll submit all the questions to the panel. So the first question, just going in order, is going to go to John Schroeder. And John, question is, has NASCO developed a formula to convert the MACP or PACP rating to more of a 0 to 100 or A to F type of rating that's easier to use and understand? John?
Can you hear me okay, Ted?
Yes.
Yes, we're in the process of updating the MACP manual to include scores on a scale of 1 to 5 for all defects, and then also have similar scores for the manhole as a whole using a couple different types of scoring systems, a quick score, a rating for both structural and O&M, and then an overall score. And that will be rolling out here in the next couple of months. We have a committee that we're working with that is reviewing that, and then we're going to put that out as an update to the MACP manual.
Yeah, thanks, John. And just this as a note, John's really been involved, as a lot of the presenters are, in fact, in the update of MACP. So we'll actually be following up, soliciting your comments on the update to MACP and as well as PACP. Next question I'm going to direct to Frank. Frank, please address the different types of injectable grout, including hydrophobic and hydrophilic differences.
Okay,
Frank?
well, that's a good question. Thank you, Ted. Can you hear me okay?
Yes.
Great, great. Typically, a contractor will determine what type of resin or grout to inject by the experience that he has, by the equipment that he has, and also by the product that he might be more familiar with. You can create a grout solution by using sometimes a hydrophilic grout, which is a grout that does not have an affinity for water, so it does not have to be around water after the product cures. You can also attack a leaking structure by injecting a hydrophilic if you know that the area is going to be hydrated after the product cures. And a hydrophilic product is a resin that requires hydration. It does have an affinity for water. Then there are also urethane gels, there's also acrylamides, there's also acrylics that can be used to go all the way through the structure wall out to create a grout curtain, as we mentioned in the presentation, to solidify the soil, stop further erosion, and create a curtain to not allow water to leave or enter the structure. I'm not sure how deep into the chemistry you want me to go. Maybe it's something that I can answer offline if there's a real specific question about it.
Yeah, no, I think that's great, Frank, and we can get more specific when we put this whole FAQ together. Thanks.
Okay.
Next question I'm going to direct to Craig, and you mentioned liquid additives. How does the liquid additive in the cementitious materials actually prevent microbial growth?
Well, as I believe Jim went over that during his presentation, but there's several things that are happening. Basically, the bacteria that is present in the manhole is feeding, and it's creating hydrogen sulfide gas, which is typically what people think is actually causing the problem. That's creating a smell, a rotten egg smell, but it's not actually the problem. The problem comes when that bacteria converts that into sulfuric acid. And the sulfuric acid is actually what is attacking the paste of the concrete and deteriorating the structure. That's why you might see it more prevalent in a precast manhole than a brick manhole, where the precast manhole could be eaten up down to the aggregate. And when it gets to the aggregate, that's a much harder surface, and it's more difficult for the bacteria to penetrate that, but they can take the top layer, which is the paste material, off of there sometimes fairly quickly, depending on the levels of that bacteria.
Okay, thanks, Craig. Jim, do you have anything to add to that? Jim, are you with us?
Are you there? Hello.
Hey, Jim.
Can you hear me okay? I'm having
Yeah.
some.
Yeah, Jim, do you have anything to add to that?
Are you saying Jim or Tim?
I'm sorry, Jim. Yeah, because the question dealt with the resistance to hydrogen sulfide.
Yeah, basically, the hydrogen sulfide, this inert ingredient that is either put in, there's only a few manufacturers. One's a liquid and one's put into a powder. And the thought process is that the constituent keeps the growth to a minimum, either using a silver agion or an electric process. I don't know specifically the technologies of the liquid, but we have been able to do it in a cement form, an additive that's pre-mixed into the bag.
Okay. Okay, thanks, Jim. Craig, I'm going to direct this next question to you. What is the expected increase in lifespan of calcium aluminate mortars over Portland cement-based mortars? And then what about 100% pure fused calcium aluminate mortars? Can you comment on that?
Well, that's a good question, Ted. It really depends on the environment of the manhole. In my opinion, there's a fair amount of manholes that in residential areas and in normal flow areas that may not require any more than a Portland cement-based product, which also has microsilica, and that also adds to the chemical resistance capabilities of the Portland cement. When you move up to a calcium aluminate, it's a harder cement, so the theory is that it's more difficult to penetrate to allow it to potentially degrade. Now, compressor strengths come into play because basically the higher the compressor strength, the tighter the pore structure, which means there's less opportunity or less availability of space for attack, either by bacteria or by chemicals for some reason. The calcium aluminate with the clinker takes the sand out of the equation and basically injects a harder aggregate that, again, is more difficult to penetrate by, again, either bacteria or chemicals. As far as lifespans, I don't want to be kind of waffling, but it really depends on the environment of the manhole. Not every manhole needs to have the same solution, whether it be a Portland cement, calcium aluminate, or an epoxy or a polyurethane. I think that goes back to what John talked about initially about inspections and doing a proper inspection and understanding what the problem is and then moving forward with the solution. But the manufacturers, typically of these products, have a very good idea of where the products fit in, what products go into what environments. Sometimes they look at pH levels. If the manhole has a lower pH, they may go with the calcium aluminate, and even lower than that, maybe an epoxy, a little higher than that, a Portland cement. So there's ways to look at it, but you need to determine what you're dealing with before you decide on a product.
Okay, thanks, Craig. I'm going to address this next question to John Manajak. John, for chimney replacement, what if the groundwater will degrade the butyl between the sections, and then what measures should be taken if that happens?
Well, if you're raising the manhole frame and you've got the area dug out around it, the exterior chimney seal would be a good option. You could put that on after you replace the rings. This way you have a full wrap and a full protection on the outside. The other option would be to put interior boots on. Since you have everything that's the same size, those boots will fit nicely in a newly constructed chimney.
Okay. All right. Thanks, John. Let me follow up. Like I said, we got a lot of questions, and we got a little bit more time, so I want to go back to looking for the questions. I'm sorry. Yeah, this one goes back to Jim Creed. Are the coatings all susceptible to failure if the manhole develops leaks after the coating is applied? And I think there was a follow-up to the one I was actually looking for as far as the ability to coat if there's moisture present. So can you comment on that?
Yes. Yeah.
This goes back to Jim Creed.
Sure. Let me take that first. Actually, the coating that goes to a damp surface, there's a term called SSD, which is a surface saturated dry. And I guess the only way to describe it is if you put your hand on the surface and there's a distinct coolness or a wetness or a dampness, but when you take your hand off, there's no glistening water. That's the tolerance of these materials. If there's water leaking or if there's something coming through, obviously we're going to have some limitations there. The first part of your question in regards to are the coatings susceptible to cracking, you know, these coatings are made to go over concrete. However, since concrete generally is dynamic, you may get cracking in the future. What we've seen is actually the manholes becoming homogeneous and issues developing outside of the manholes that have caused issues. But if that concrete cracks, and if it cracks at a rate more than the coating, yes. That's why, again, you know, I think everybody has preached the fact that each one should be looked at differently, and maybe that one should have required an elastomeric polyurethane that had a, say, 50% elongation. That's you know, that's kind of a roundabout way to answer that question, but I hope it did for you.
Okay, thanks, Jim. And again, we're gonna move on, but again, just a reminder that we will be publishing the answers to these questions. You know, we're getting questions, we're getting comments. You know, we'll be putting all that together. It may take us a little, you know, some time to put this together, but we will be following up with the email addresses that you actually provided when you registered for this. We'll be following up with links to all the answers to these questions. So we're going to go ahead and move on now. Our next speaker will be Tim Back. Tim Back will discuss specifications for manhole rehabilitation. Tim's a professional engineer with Back Municipal Consulting. He has 21 years of experience in trenchless technology, specializing in rehabilitation. He has extensive experience with construction management, inspection, and testing of trenchless projects. He assists municipalities in the Midwest on I&I reduction and trenchless product selection. Tim has a bachelor's degree in civil engineering from the University of Cincinnati. He's a certified trainer for NASCO's Inspector Training and Certification Program, which he did help develop for manhole rehabilitation. And he currently serves as the chair of the Manhole Rehabilitation Committee for NASCO. He's also a former professional boxer. So, Tim?
Thanks, Ted. Welcome, everyone, to the specification portion of this webinar. NASCO is committed to providing up-to-date standards for the sewer industry. I'll be talking about the recent version of the NASCO manhole rehabilitation specifications. This presentation, however, will only cover the highlights of the specification. To stay current, NASCO reviews their standard specification for accuracy and relevance within the sewer industry. The recent Manhole Rehab Committee determined that it was time to revise the manhole rehabilitation specification. A couple of key items were in need of revision. There were items in the specification that were just marketing based. They also saw them require more engineering into the design. In addition, they wanted to emphasize that the manufacturers are the experts and the recommendations should be followed. The new version of the specifications was developed by members of the Manhole Rehab Committee. This included 4 engineering firms, 7 manufacturers, and 2 contractors, and took about a year to finalize. The rehabilitation of manholes can be complicated, and the selection of the correct product or technology can at times be confusing. There are many methods available for rehabilitation of manholes. Each method must be evaluated to determine its applicability to provide the correct solution for the best available price. The following are some of the manhole rehabilitation components covered in this specification and also in this webinar. Chemical grouting, cementitious manhole restoration, polymers such as epoxies, polyurethanes, and polyureas, cured-in-place liners, panel liners, chimney seals, and bench and channel inserts. The purpose of manhole rehabilitation is to protect the manhole structure against corrosion, seal it from I&I, rebuild it structurally, or a combination of all 3. One of the items contained in the specification is that the system manufacturer must submit to the owner a minimum of 14 calendar days in advance of the bid date all required product information to obtain pre-approval system status. The contractor shall submit a performance work statement at the pre-construction meeting. The performance work statement shall at a minimum contain the following. Certify at the time of bid that the designated manholes were visited, inspected, and evaluated by the contractor. A detailed installation plan describing all preparation work, cleaning operations, pre-inspections, bypass pumping, traffic control, the installation procedures, method of curing, quality control, testing, to be performed, final inspection, and warranties. A detailed installation schedule shall be prepared and submitted. The contractor's experience for each type of rehabilitation component, the name and experience of each lead individual performing work of each component. All tools and equipment required for a complete installation. The performance work statement shall identify which tools and equipment will be redundant on the job site in the event of equipment breakdown. A detailed description of the contractor's proposed procedures for cleaning and preparing the manhole structure shall be submitted. The contractor will describe in detail what substrate testing will be performed by the contractor to verify acceptability of the system material to be applied. The system material type and manufacturer to be used, including catalog data sheets, ASTM references, material composition, manufacturer recommended specifications, component physical properties, and chemical resistance, and detailed description of the recommended procedures for handling and storing materials. Manufacturer's detailed description of the recommended material installation or application process, including mixing, additives, set time, cure time, and the return to service, all shall be submitted. Manufacturer's detailed description of all required field testing processes and procedures. Copies of independent testing performed on the rehabilitation component indicating that the product meets the requirements of the manufacturer's design. Manufacturers are the experts of their technology. They are typically the ones that keep up to date with advancements in raw materials that apply to their technology. They are the ones with the most experience with their product and are familiar with the changes. Their recommendations should be strictly adhered to. The contractor is required to have the following minimum experience: 1,000 vertical feet in the previous 3-year period, 3 successful years of installation, 5 recent verifiable references using the same material that's proposed. A detailed quality assurance plan shall be submitted to the owner. It must contain a detailed description of the proposed quality controls to be performed by the contractor. Contractor safety needs to be a little bit more than what these guys are doing. At a minimum, the contractor shall have on the job site at all times a gas monitor, a confined space access and retrieval winch system, safety harness and lifelines, ventilation fans, and supplied air respirator if needed. The manufacturer and contractor shall warrant the system to be free from defects in raw materials for 1 year after the installation or from the date of acceptance by the owner. The owner shall perform at its own cost warranty inspections with its own personnel or personnel independent of the installation contractor. 10% of manholes rehabilitated shall be inspected at locations randomly selected by the owner. No infiltration or inflow shall be visible. Preparation of the manhole must include cleaning the interior surfaces of the manhole to eliminate debris, dirt, oil, grease, and remains of old coatings. Remove loose mortar and concrete. Pressure washing levels used for cleaning shall be as recommended by the manufacturer, and also repair irregularities in the manhole. Repair leakage in the manhole using compatible material that are compatible with the proposed resurfacing material. Trim and grout incoming laterals and pipes as required. Remove debris from manhole and incoming sewer connections. Properly dispose of debris and residue from cleaning and other construction operations in a manner satisfactory to the owner. And remove the steps flush. I'm going to cover just a few items for some of the technology. Most of that has been covered in previous sessions. For grouting, ASTM 2414, standard practice for sealing sewer manholes using chemical grouting, should be followed. Grout typically shall be injected through the lowest holes first. The injection holes shall be cleaned and patched. For cementitious manhole restoration, ASTM 2551 shall be followed. Product shall be applied using equipment specifically designed for troweling, low-pressure spray, or spin casting. All cementitious liners shall be troweled to densify and smooth out the surfaces. For polymer systems, strict adherence to the manufacturer's installation procedures shall be followed. Product may be troweled, sprayed, or spin cast. Manufacturer shall determine the recoat window. Cured-in-place liners can either be pre-made liners or tube liners. Pre-made liners are custom fabricated and can accommodate a variety of manhole shapes and sizes. The tube liner system includes a constant diameter tube that is stretched to fit a range of manhole sizes and lengths. Composite liners shall be a multi-layered composite comprised of layers of epoxy and fiberglass, handcrafted and constructed in place and cured at ambient temperatures. Fiberglass must be overlapped a minimum of 3 inches. Each of these products must be installed according to the manufacturer's recommendations for chimney seals. Systems may be designed to rehabilitate the existing manhole against corrosion, I&I, structural buildback, or a combination of 3. If a manhole is specified to be structurally renewed and able to sustain all earth, hydrostatic, and dynamic loading without support of the existing structure, certification and submission of design calculations by a registered professional engineer is required. If a manhole is specified to be structurally rebuilt with buildback materials or rehabilitated to sustain hydrostatic loading by groundwater, certification and submission of design calculations by a registered professional engineer is also required. All design must be supported by third-party testing and documentation for the exact product that is being submitted. If a manhole is specified to receive a corrosion protection coating sufficiently thick to totally protect the existing host structure from further corrosion, deterioration, and water vapor transmission, certification and submission of design calculations by a registered engineer may be required. Some of the quality assurance and testing measures requires the contractor and owner to keep a chain of custody. The contractor shall perform all testing in the presence of the owner's representative. 10% of the installed systems shall be tested. If more than 5% of the tested systems fail the test, then an additional 10% of the manholes are selected for further testing. This process continues until the systems tested meet the requirements. All manholes shall be visually inspected. Any leakage into the manhole and areas where the systems were installed by the contractor shall be identified. ASTM C109 shall be performed on cementitious products. During the application, a wet film thickness gauge, meaning ASTM D4414, shall be used to determine thickness. If the entire manhole, including invert and pipe penetrations, is rehabilitated to as-new condition, then a vacuum test may be performed according to ASTM F1244. If vacuum test fails, then the contractor shall spray the entire manhole with a soap solution and retest. Inspector shall determine if failure was due to improper rehabilitation or poor pipe condition or improperly seated plugs. If the inspector determines that the failure is due to improper rehabilitation, then the contractor shall repair according to the manufacturer recommendations and retest until a successful vacuum test is achieved. If the inspector determines that the failure was due to poor condition of the pipes or angular space between the pipe and the pipe liner, or the inability to seat plugs properly, and that there are no visible defects in the applied product, then it will be determined that the manhole has passed. Where specified, a minimum of 10% of the manholes coated shall be tested for adhesion of the coating to the substrate. Testing shall be conducted in accordance with one of the following: ASTM D4541, D7234, or NACE SP018. Owner's representative shall select the manhole to be tested. Holiday detection shall be performed for all coatings installed in corrosive environments. All touch-up and repair procedures shall follow the coating manufacturer's recommendation and then retested. Some of the sample bid items include mobilization as a lump sum, system lump sum or per vertical foot, system inspector training, replace manhole frame and cover per each, manhole adjustment materials per vertical inch, bench rebuild per each, manhole steps reinstall per each, and inverts. And in summary, the specifications contain less marketing. It is focused on manufacturer knows best, requires third-party testing, and engineer stamp designs. Thank you for your time, and back to you, Ted.
Thanks, Tim. Our final speaker will be Jerry Munchmeyer. In addition to serving as technical director at NASCO, Jerry is the principal of Munchmeyer Associates, LLC, where he provides training and consultation to the pipeline industry. Jerry has an incredible 50 years of experience in the pipeline industry, including 30 years in the development, design, and construction of trenchless technologies. During this time, he either developed or co-founded NASCO's PACP, the Pipeline Assessment Certification Program, along with MACP for manholes and LACP for laterals. The NASCO Inspector Training and Certification Program, ITCP, for both cured-in-place pipe and manhole rehabilitation. The Rehab Zone, which is an international display of pipe rehabilitation technologies. Along with that is what's published every year called the Technology Guide. There's been several questions about, is there any kind of guide that provides different technologies available? If you can get your hands on the Technology Guide, it gives a lot of that information to you already. If you want a copy, we can certainly get you a copy. Let us know. And then also the NASCO performance specifications that we've alluded to quite a few times so far during this webcast, and Jerry's going to talk more about that, and they can be downloaded for free on NASCO's website. And finally, the International Pipe Roasting Association, which is a division of NASCO. Again, Jerry actually either developed or co-founded all of those, to name a few. Jerry's a registered engineer, frankly, in too many states to mention here, and was inducted in the Order of the Engineer in 1989. Last year, he was inducted into NASCO's Select Society of Sanitary Sewer Sleuths, the 5S Society. And in February this year, was the recipient of NASCO's Trainer of the Year. Now, even more recently, I'm proud to mention that Jerry has achieved recognition as the 2014 Trenchless Technology Person of the Year. So with that, Jerry?
Well, thank you, Ted. Wow. Were you talking about me?
Yeah, that takes a long time to introduce you, Jerry.
Okay, we've heard a lot about the different technologies and the different materials and how good everything is, and let's talk a little bit about verifying that. And the way we verify that is we're going to talk a little bit about inspecting these coatings and, of course, testing them. So the first thing we have is a poll question that Rebecca is going to put up here, and we're going to go through it real quick, and you will have a chance to respond. Rebecca, I can't see it, so.
The question is, what is the best approach for visually inspecting and testing a manhole before and after product installation? And the options are from the ground service or from inside the manhole. We have about 30% of people voted, so I'll keep it open for a few more seconds. All right, I'll go ahead and launch those results for you, Jerry. It's
Okay.
84% from inside the manhole and 16% from the ground surface.
Oh, okay. Well, so let's proceed with my suggestions. Inspection and testing for manholes, manhole rehabilitation is really necessary. Obviously, it is. Those of you who've been in the industry for a number of years can attest to that. Installation of coatings and linings do require a certain amount of attention out in the field, and it does require a trained inspector to be out there. So the second thing is the inspector, does the inspector need to be trained? The answer also is yes. Unfortunately, I've discovered over the last 10 years or so that a lot of people know a lot about everything, but we haven't really, until we've developed these programs for NASCO, have really provided some in-depth training to the inspector. So yes, the answer is yes, the inspector needs to be trained. So what should the trained inspector be inspecting out there? So we've talked about all these products. Let's talk about some of the details. We can look at pre-application. There's some pre-application things that need to be inspected that are very important. The host structure preparation is probably one of the most important things that an inspector could be looking for, because if the preparation has not been done properly on the manhole, then probably the long-term design of that coating will probably be shortened unless that preparation is done properly. Host structure surface condition, such as testing it for pH, moisture conditions, and applied material quality. So there are things that can be done during pre-application. During application, we can look at material quantity, checking of the quantity. We can do some material testing. And we can also, of course, inspect the curing conditions under which the material is being applied. I think Jim mentioned, you know, there's a big disparity in coatings, whether it's totally dry or whether it's surface dry condition, or is it water tolerant, such as some cement. So these are important things that an inspector can actually check during the application. And after the application, the visual quality, the thickness that was applied, if it was not measured during the application, it needs to be measured after application. Adhesion to the host structure. Is it supposed to bond to the host structure? Well, we need to test that. Monolithic application talks about putting on a lining or coating that is completely defect-free. It encapsulates the entire structure in the case of manholes from the inside. And then, of course, any leakage testing that can be done after the application to make sure there's no inflow or infiltration coming in after the rehabilitation is complete. So we've talked about some of the forces already that affect a manhole. We have external I&I. It affects different, the inflow affects the manhole a little different than the infiltration, but they both affect a manhole and how it functions. External soil loading, external live or dynamic loading, those that are in streets or airports or in areas where they may have some fairly heavy loading, those all affect how a manhole will function. And of course the internal corrosion and erosion, which by the way is becoming, probably will become more serious as time goes on, only because of the large program we're undergoing right now of removing clean water out of our collection systems. There's big impetus on that, EPA consent decrees and things of that nature. So I suspect corrosion is going to be another, more of a major factor, even more so in the future, because the sewage will be much more concentrated. So the methods, we've already talked about the methods. I won't go into detail, just a quick summary. Grouting, you got cementitious, polymer coatings, cured in place linings, panel linings, and there's replacement techniques of components, and of course slipping in a replacement vertical component into the existing manhole as a full structural replacement. So there are a number of different ways they can be rehabilitated. But each one requires installation quality, and of course, someone that's out there that has some education, some training on exactly what needs to be done so you can get a long-term product. Let's talk a little bit about a subject that's commonly discussed in this industry is the material bonding. Okay, we've got different products claim different bonding, but what does it really mean? I just want to, just as a concept, I'd like to just discuss chemical bonding, for instance. Chemical bonding is when a product is applied over its same product, but within what we call a recoat window. It actually will chemically bond to itself. In other words, the molecules will connect up and you will have a chemical bond. Most products, however, are what we call mechanically bonded. There's a cold joint between two different materials, requires that the surface be properly prepared, the surface be properly cleaned and ready to accept another product. And that product needs to be able to grab onto that surface and mechanically bond to that surface. So this basically indicates there, especially with mechanical bonding, there's just some major or key preparation requirements that are required to be able to really get this mechanical bonding. The other thing we need to look at in any type of rehab technology is the product life. How long is the product going to last? Well, we can divide that into two separate definitions. We can divide that into design life, which is design of the life of the product itself. How long is it going to last? And we can also say, well, what's the service life? Well, the service life is, yeah, the product's there. It hasn't deteriorated. It hasn't corroded. But is it functioning the way it should be functioning? For instance, is it protecting the product from corrosion? Perhaps. But is it still stopping leakage from coming in? Perhaps or perhaps not. Then the service life has no longer been met if it begins to leak again. So again, these are the things we need to look at while we inspect these projects and make sure that both the design life and the service life are met. Product inspections need to be measurable, so they need to be specified. The contract specification, as Tim talked about, and he talked about it in very detail, need to specifically define what the inspection requirements will be for infiltration inflow, prevention, structural capabilities, including testing, the bonding capability. If it is a product that is meant to bond to the whole structure, then it requires certain inspections, and these are all measurable. Pinholes, which means coating without any defects in it, without any flaws in it, and that all can be measured. Corrosion resistance, and that all can be measured based on testing and based on certifications from the manufacturers of the products. So let's talk a little bit about inspection and testing methods commonly used for manhole rehabilitation. What you'll find, there are many procedures out there that are available to the customer. Before rehabilitation, obviously visual inspection, very, very, very important. Visual inspection should be done, obviously, from inside the manhole, not from the surface. There's very, very little that someone can see, particularly vertical parts of the manhole that may be tapered backwards that you can't even see unless you actually go down into the manhole. So visual inspection, extremely important, and this is before the application to inspect the actual surface of the structure before the coating is applied. So this is applicable to all manhole rehabilitation. Surface preparation inspection, as I said, down in the manhole to affect certain procedures to make sure that there is no loose material remaining on the manhole wall, that the manhole wall has been prepped properly, and it's essentially applicable to all products designed to bond to the whole structure. We've talked a little bit about moisture levels. This is something that is
usually defined by the technology manufacturer, not the applicator. The manufacturer will determine is, can this particular product be applied on a damp or wet surface, or does it need to be saturated surface dry, which, as Jim said, it feels cold, but it's not wet, or does it be perfectly dry, where there's no real cold or moisture that may be at the surface. So different products have different requirements, and these are defined by the manufacturer. There are such things as water vapor transmission through the wall of the manhole, as per ASTM D4263, and it's usually applicable to thin, mechanically bonded coatings that may be affected by water vapor transmission through the wall. In other words, if there's water coming through the wall, and we can test for those things, then that over time will tend to disbond the coating, and it will begin to peel off. And once it begins to peel off, then of course it'll totally fail just over a matter of time. There are pH tests out there, which is the pH of the concrete wall before the application of the new coating material. And as Jim also said, this is a technique for determining what type of product is best applied. Is it a low pH? Is it a high pH? Does it require a polymer, or does it require a concrete or cement type surfacing? So these are things that can be checked very, very effectively. And during manhole application, there are some inspection methods that we can look at. Your material thickness can be measured during the actual application. This is typically applicable to a product that doesn't set up very quickly, such as an epoxy. It can be measured. The gauge has a just different depth gauges on it that the applicator can actually penetrate into the wall of the coating and give the inspector a reading at any point during the application of what the thickness of that coating is. And if the coating has a particular specification of, let's say, 125 mils, then he can verify that, well, he's only got 60 on at this point. He has to put another 60 mils onto the wall. So he can, the inspector can have that checked on a periodic basis as the material is being applied. Your slump tests, pretty common in the industry, very important for cementitious products to make sure that the water-cement ratio is correct, and that can be something that is specified by the manufacturer and then inspected by an inspector by doing a slump test out in the field. Your standard cube testing methods. These are typically methods that are used for cementitious build-back materials, spray-on materials, trowel-on materials, where the material is placed into these small 2x2 cubes. Those are then sent to a laboratory for testing. It is an ASTM C109 recommended standard. As an alternative to this, some contractors prefer to use cylinder tests, very similar to what we do with concrete when we install concrete. Cylinder tests are defined under ASTM C39. It's an alternative to a cube test. And again, it's applicable to testing the physical properties of a cementitious material used for structure build-back. So here are some things that should be done on a regular basis to determine that the product is as per specifications and being installed correctly. Grouting, we talked a little bit about grouting. There's a gel test that can be done before the grout is actually injected into the ground. And this is simply by taking a portion of component from each of the gel components from the application equipment and doing a quick gel test, which is a matter of pouring one material into the other material and back and forth, and then just basically getting a time on how fast it gels. Very, very simple test out in the field, but it will tell you, it will tell the inspector that, yes, the material at this point in time will gel, and he can document that. So this is applicable for measuring grout gel times prior to application. And then, of course, there's some things, obviously, that we can do after the application of the coating. Again, visual inspection. That's a repeat. But we want to look at the finished product. Because no matter whether we do linings or coatings or whatever product we use, we want a final visual inspection. It should be done by an inspector to make sure it meets the requirements, it doesn't have any flaws in it, doesn't have any obvious blemishes or delaminations that would affect the longevity. So applicable to all materials to verify visual conformance to the contract documents. The core testing. Core testing is a way of actually removing a small core out of the material that was applied to measure the final thickness. This is a measurable thing. This is a measurable specified requirement in most contracts, and so it can be measured using a core test. Ultrasonic test is a non-destructive way of testing the thickness of coating. Many contractors use this as opposed to actually cutting a sample out and then having to repair that defect. This is applicable, again, for testing the coating and liner thickness by ultrasonic testing of the installed product. Very, very common way of testing the thickness. Adhesion pull-off tests. Pull-off tests are typically done to make sure and to verify that the product has properly adhered to the structure surface. And this is where the preparation and the pre-cleaning and pre-testing becomes very, very important. And you can see on the two slides, the darker one is where this dolly that is glued to the coating has been pulled off, and we can see substrate material, not just the coating, but substrate material, which tells us that the substrate has actually failed during the pull and not the adhesion or not the bond of the coating to the substrate. And the second one is obvious, where the coating has pulled right off of the substrate and did not bond very well. So we want to test for those things because we want to make sure that the product has adhered properly. If it has adhered properly, you probably have a long-term solution. Spark testing, we've talked about that. This is pretty common to all technologies. And spark testing will determine if the project or the application has been installed monolithically. In other words, monolithically meaning there are no pinholes or no defects or thin spots or issues in the coating that will prevent or will cause it to prematurely fail. Those of you who are familiar with most coatings, if a single spot on a coating begins to deteriorate and the corrosive environment gets under that coating at that point, over time that will find its way under the majority of the coating, and the coating will tend to fail in its entirety. So it's important, and virtually for every technology, that they be spark tested to make sure that they are 100% monolithic and have no defects. Vacuum testing, I think Tim talked about this a little bit. I just want to emphasize vacuum testing was developed for new manhole construction, but where specified, if the entire manhole, including the invert, pipe penetrations, and anything else that has to be fixed on the manhole are properly repaired, then a vacuum test can be performed. A vacuum test should not necessarily be performed if only one component of the manhole is rehabilitated. It needs to be the entire manhole. Quick summary of the pre-installation the systems, the test approaches you can use, the during installation approaches for inspection, and of course after installation. All of those are defined in either a standard or an ASTM, and they are available for the inspector to be able to define and verify that the material has been installed properly. So in summary, industry standard methods for verifying the quality of the applied products are available for each phase of manhole rehabilitation to provide the trained inspector with the tools to inspect and test the manhole product application. So the tools are there. We need to define them as engineers. We need to define that in the spec and have an inspector out there that then verifies these. With that, I'll turn it back to Ted.
Thanks, Jerry. We're going to jump right into the questions. We've actually got a few general ones I'll mention. They're asking about where to get copies of the specification guidelines that a lot of this is based on. And if you get on the NASCO website, which is nasco.org, under Publications and Specs, you can find copies of these the manhole rehabilitation specification guidelines as well as others. So you can actually find that right on the website. There's also been a few questions about finding the technology guide. And currently we don't provide that electronically, but if you can send us an address and just let us know that you'd like that, we can send that to you. I know a lot of our trainers for either PACP or ITCP provide that with their classes. I know I do for all of my classes. It's a great document, and like I said, just let us know. If you go into the website under Contact Us, just fill that out and let us know that's what you want. We'll get you a copy or multiple copies if that's what you want. Going back to the questions again now. First one I'm going to ask for a comment from Tim, and the question was to comment on the warranty of only 1 year. Can you give a comment on that, Tim?
Well, not knowing, well, the 1 year seems to be the standard. However, there are municipalities that require more than 1 year, and contractors and manufacturers that will give more than 1 year. However, the general consensus of the committee was to have a minimum of a year. That's what's given typically in new construction, so that's what was decided on. But certainly, if you are a municipality that feels strongly about additional warranty, I know contractors and manufacturers will offer 2 or 3 year warranty. In some cases, there are manufacturers that give a 10-year warranty.
Can I comment on that too, Ted?
Yes, absolutely.
Yeah, I would like to, on the subject of warranties, any warranty that is required, number one, needs to be backed by an insurance company, so that an insurance company, in the event the contractor does not perform or does not come back and fix the project or whatever, then the insurance company will prevail. So that's a guarantee the customer needs to have. It needs to be backed by an insurance company. The other thing is, if there is a defect in the manhole or there is an issue, then extended warranties are always something that can be asked for by the by the customer. It's just a matter of specifying it that way. Okay, and so just really some thoughts. Having an extended warranty for manhole rehabilitation, the last thing I'll leave you with is, unlike other products, coatings and linings have to be inspected much more frequently during the warranty period, maybe more than once, to make sure that there is not an issue that can permeate over time and cause the entire project to fail. So, and that's something we teach in our courses.
Yeah, and the comment that the 1 year, obviously that can be adjusted, but there's like Jerry, like you said, there's bonding considerations and insurance considerations, obviously, that you need to be prepared to deal with if you're bidding it that way. Next question. There were several comments on manhole steps and how NASCO's position on replacing the steps, and frankly, as far as replacing the steps, that's really generally the owner's decision. NASCO's position would be that the appropriate safety precautions, manhole entry procedures, PPE, all of that is used appropriately, whether they're steps or not, or whether they're replaced. One question, however, was if the steps are removed, can they be added later? And maybe either Tim or Jerry, can you comment on that?
Well, I'll respond to that. The answer is absolutely yes. As a matter of fact, Tim, a normal procedure would be to remove the steps, then apply the rehabilitation technology, then core new holes for the steps, insert the steps, and then put a protective filler or something to fill any open space with a step may not have filled up the hole properly. So that is, again, fully sealed. So it requires not only coring a hole into the new surface, putting the steps in, but then also filling that with a protection material, so you get again a totally monolithic installation.
Okay, let me try to. We got just a little bit of time left. There's a couple of questions, and Jerry, I'm gonna direct this to you. Can the visual manhole inspection be done via manhole pole camera or video?
Depends. I would recommend not, and I kind of base that on your typical NACE inspection requirements and SSP requirements for coatings that are pretty standard in the industry. To do a pre-inspection, the inspector actually has to go down in the manhole and see and physically feel if there's any material coming off that wall. You cannot see that with a pole camera. And in a post-inspection, depending, I'm not going to, say an HD camera might not do well, but in order to see a pinhole or to be able to determine if there's a hollow spot where the coating has not adhered to the surface properly, which can only be done by going down into a manhole and lightly tapping the coating in some key areas where it might be suspect. It can only be done from entry. It can't be done with a pole camera.
Okay, thanks, Jerry. I'm going to have to. We got about a minute left before we're going to move on. So, just kind of in closing, I'm really excited about the number of questions. I'm sorry if we couldn't answer them as part of this webcast, but as I mentioned before, we'll be providing all the meeting participants based on the emails that you provided in your registration with a link to answers to all of the questions raised in this webcast. Give us about a week or two or whatever it takes, because we're going to be having all the panelists actually address all of your questions. If you did not register yourself, again, you can go on the NASCO website and go into the contact us. You can certainly give us that information. That would be great. We'll certainly add you to the list, as well as the technology guide and anything else that we can do to help you. I mentioned where to find the specifications in the NASCO website, and again, we're going to follow up with emails to all the registrants on where you can download the most recent manhole rehab specification guidelines, which are were actually just completed in December of this past year, as well as other specifications, cured-in-place pipe, chemical grouting, and many others. As Rebecca mentioned, for those of us that need continuing education credits, by electronically completing the evaluation form for this webcast, you can receive the PDHs for this webcast. And finally, this webcast will be available both through WEF and NASCO. You can find the NASCO webcasts that we've already done, the two of them, on our homepage, www.nasco.org. You can view those and actually get the PDHs for them, again, by completing the information. So with that, to kind of close, I'd like to, again, express our appreciation to you all, but particularly the sponsors that really made this webcast possible. And frankly, there's been a lot of questions that I really didn't get a chance to get to about some of the people that have been talking specifically Avanti and Parson. And at this point, I'd like to turn it over to them, starting with Avanti.
Well, thank you, Ted.
Okay, Don?
Yes, sir. Thank you. Can you hear me okay?
Absolutely.
Okay, good. The uptick and resurgence of chemical grout based on the number of specifications from the engineering community is really encouraging, really encouraging. Because education is the core value of Avanti, I'd like to invest the next few minutes to increase your understanding of chemical grout as both a proactive maintenance practice and an engineering construction project. Let's begin with with the basic chemistry of an acrylic grout. So the component is only 10% by weight of the total final product. Acrylamide monomer is the primary ingredient. Monomer, from the Greek mono, meaning one, is a molecule that binds chemically to other molecules to form a polymer, whose structure is composed of multiple repeating units. This polymerization process, whereby this water-like grout becomes a firm gel, is controllable. It may be set as fast as 5 seconds or delayed more than 10 hours in order to achieve greater permeation. The end result is an interconnected molecular structure which is impermeable and cannot be reversed. So what is chemical grout and how is it used? It's a liquid resin that turns into an impermeable solid in a predictable time frame, used to stop leaks above grade structures, stop infiltration in below grade structures, stabilize soils, control groundwater, and seal the annular space between hose pipe and liner. Avanti is responsible for dozens of formulas, which each are engineered to perform different tasks. Ingredients can be added to change the outcomes. So this is technology that you can control, and it's technology that you can specify, and what you know absolutely matters. There are 3 grout families: acrylic grouts, polyurethane grouts, cementitious grouts. These are tools in your toolbox. But for municipal grouting, by and large, the most significant specification is for acrylics, and for good reasons. It is the thinnest product on the market. There are no suspended solids, which is why we use a gel or a dye oftentimes for Part A and Part B to make sure the pump's working accurately. Field adjustable cure times, field adjustable gel strengths, soap and water cleanup, no activated moisture, no need for solvents, and a very successful track record. In fact, a 60-year track record. The use of a chemical grout, specifically acrylamide, dates back to 1950s for soil stabilization. In the 60s, municipalities started using the same grout to stop water leaks in mainline sewers. In 1985, U.S. DOE began an exhaustive study of 7 different grout formulations, and after 60 years, in multiple industries, new uses of chemical grout are on the horizon. This 20-year study from the DOE concluded that the best product to encapsulate radioactive waste is AB100 acrylamide grout based on its longevity of 362-year half-life in the soil. Here's an image produced by the EPA in 1990 that shows sources of inflow and infiltration. This is what we've inherited. This updated image shows a deteriorated brick manhole, a faulty lateral connection with the sanitary sewer, as well as a couple suspicious taps on the far left-hand side. Note the relationship between the storm sewer and the sanitary sewer. Let's take a closer look. Typically, the sanitary sewer runs deeper than the storm. After a rain event, exfiltration occurs and water follows the grade along the bedding, which literally acts as a French drain, channeling storm water toward the sanitary sewer trench. Hydraulic pressure is significant, and the water wants in, or it travels downline to the next manhole. Eliminating water intrusion at the manhole is good, but only part of the solution. If you think like water, you'll flow to the next point of entry, either joints in the main line, lateral connections, or the first few joints in the lateral. To permanently solve infiltration, eliminate 50% of the flow to the treatment plant, a systematic approach attacking all 4 points of infiltration is required. I'll let you read this quote from the 2009 report card on infrastructure. But what this underscores is typically we wait until the point of failure before acting versus proactively maintaining our systems. And it's pretty easy to build a business case for proactive maintenance when viewing these investment guidelines. Why not invest $1 in proactive maintenance that lasts for generations, rather than wait until more expensive structural repairs are required at $3, $4, $5, or even $10 to replace? If the goal is to eliminate infiltration, chemical grout is the only technology engineered to mitigate groundwater at every point of entry. Here are a few standards from ASTM, and kudos again to NASCO for driving the adoption of these specs among municipal, contracting, and engineering communities. As a leading producer of chemical grout for municipalities, Avanti is equally aligned with the cause of proactive maintenance before more expensive structural repair is required. It's the right thing for the ratepayer, for the health and safety of citizens, and the growth of the community. We inherited an infrastructure we can't replace, but we can make it whole for future generations if we stop the vicious cycle of waiting for it to fail. End of sermon. Thank you very much for the opportunity to sponsor this webcast.
Thanks, Don. Craig with Parson.
Thanks, Ted. Our company was founded in 1985 with the concept of providing quality products and superior customer service to the manhole rehabilitation market. Today, we have the most comprehensive line of products in the industry. Throughout our 29 years, we have always strived to treat our customers with the utmost respect and make promises that we expect to keep. Our first product was the Parson manhole insert to stop surface water inflow, the first I in I&I, from entering through manhole covers and ultimately into the treatment plant. Treating that clean water costs hundreds of thousands of dollars annually. Installing manhole cover inserts is the easiest, most cost-effective way to dramatically reduce inflow and substantially lower those costs. We offer both HDPE, plastic, and stainless steel models, plus another that eliminates odors from manholes some residents may complain about. Stopping infiltration is a necessary but fairly easy step in tightening up your manholes. Parson Quick Plug is an easy-to-use, fast-set hydraulic cement with a set time of 1 minute that is capable of stopping small to medium-sized leaks. For higher volume leaks, we recommend urethane grouts. Parson Seal Tight is a hydrophobic urethane that is dispensed from a dual caulk gun. It has an initial reaction time of about 5 seconds and can stop active leaks up to 50 gallons per minute. Parson Hydro Grout and Permaseal are injected through the manhole wall using injection ports and pumping equipment. Some rehabilitation projects could require repairs to the manhole bench and invert. The repair products need to be easy to apply and set up quickly. Parson RPM is a cementitious product that has a set time of about 30 minutes. It can be used for repairing the invert or patching the bench, as well as other areas in the manhole. Parson Epoxy FS1 is an epoxy coating that is 100% solids, can be brushed onto the invert or bench, and has a set time of about 45 minutes. By far the best and most cost-effective means of providing structural integrity to either old, poorly constructed, or deteriorated manholes is with the application of a high-strength cementitious lining. Parson offers a complete line of these products that can be hand-applied, gun-sprayed, or spin-cast in place. Parson MH Liner is our Portland cement-based product, microsilic enhanced, fiber reinforced, that can be applied up to 3 inches thick per coat. Parson CA Liner 100 is a calcium aluminate cement-based lining product for use in lower pH, higher corrosive environments. Parson CA Liner 100 Plus combines calcium aluminate cement with calcium aluminate aggregate to provide an even higher level of protection. Conblock MIC is a liquid additive used with either MH Liner or CA Liner 100 to eliminate microbial-induced corrosion, which is the primary cause of deterioration in manholes. It basically removes the food source for the bacteria, thereby starving them. Parson Epoxy SCL 80 is a high-build, 100% solids epoxy coating used for corrosion protection. The product can be brush or spray applied up to 80 mils thick in a single coat. Parson Epoxy SCL 80 HB is an ultra-high build, 100% solids epoxy coating with application thicknesses that can reach 125 mils per coat. Our composite liner system provides both structural integrity and corrosion protection with unique same-day application. Parson provides both a hand-applied and a mechanical chimney seal. Parson Epoxy FP is a brush-on, flexible epoxy urethane hybrid coating. Flex rib seals are manufactured from EPDM rubber and are installed using 2 stainless steel bands that are locked in place. We offer lightweight, compact, cost-effective application equipment for all of our rehabilitation products. Our Pro 50 starter package is all electric and capable of gun spraying any of our cementitious linings. The mortar spinner can also be used with this equipment. Our epoxy sprayer is used to spray or spin cast Parson Epoxy SCL80. The grout pump is electric and used to inject Parson Hydrogrout and Permaseal. Our company also offers several accessory items for manholes. All of us at Parson Environmental Products sincerely appreciate the time you spent with us today, and we look forward to helping you ensure the successful completion of your next manhole rehabilitation project. Thanks very much again for your time. Back to you, Ted.
Thanks again, Craig, with Parson Environmental, and thank you to Don Rigby from Avanti. Just want to close by saying, we've gotten some questions about, what the technology guide specifications, and I just want to reiterate, NASCO is a nonprofit organization. Our mission is to improve the success of our industry. So in doing that, we want to get good educational information out to members and non-members alike. Technology guides, specifications, these things are absolutely free. If you need them, by all means, you can download the specifications or send us your information, and we can send you the technology guide at no cost. So based on the questions, there's a huge amount of knowledge in this group alone, and I'd love to get each one of you involved in helping us with this industry, develop and help improve this industry. So we hope you enjoyed this webcast and hope it helps improve your projects. Thanks, and have a good day. Bye.